So as we mentioned before, now we will see few set of questions, okay, based on antennas or RF concepts. So now actually previously we covered 6 questions. Now we will see 7th question. So if antenna is of size 10 lambda bar 10 lambda at 5 gigahertz, okay, has the gain of about 10 dBi. When same size antenna designed at the frequency of 10 gigahertz, okay, then what will be the gain at that frequency? Okay, so answer is very typical because so you have to remember several concepts like antenna is of size, antenna is in the order of antenna size is in the order of wavelength. Okay, so what will happen when wavelength when frequency increases to the wavelength, and what will happen when low frequency? So what will happen to the gain when frequency increases? So that you have to see, because it can be high. The answer there list of answers are given, and possible answers, but you have to choose appropriate one, like correct one. Higher gain that of the 5 gigahertz, lower gain at the 5 gigahertz. Whether it will have equal gain, the same size we are saying, but you have to think in frequency, wavelength on those, and how the gain will vary according to the frequency, and those lines you have to think, and then you can answer. You should be able to answer this question. Okay. Next, 8th question is antenna radiation patterns can be measured using directly at near field without using scatter. Is it true? So you have to think. Okay. So antenna radiation patterns can be measured directly at near field. Okay. So you must remember what is the concept behind the near field measurements, like what we covered in the previous presentations. So what is compact antenna test range? What is radiation patterns is measured directly. So these are all the 3 keywords are there. So you have to think on these lines, and then you should be able to answer this question. Okay. Good impedance matching enhances the power transfer, therefore SNR. Is it right? So you can remember 3 keywords: good impedance matching, which enhances the power transfer. Okay. Therefore SNR. So this is a straightforward question. Next is state the law that describe the change in magnetic field result in change of electric field. Okay. So which law states that? Okay, that you should go through. Change in magnetic field results in change of electric field. Remember, change in magnetic field results in change of electric field. Which law is that? Ampere law? Is it saying that? No. I'm sorry. So I should not say answer. Ampere Maxwell law? Is it Faraday's law or Gauss law? Okay. So you have to. It's a straightforward question. Next is at far field E and H fields are orthogonal but not in phase. Is it true? So what is far field? What will be the nature of the far field and the nature of the wave in the far field? That you should know, because I think I have covered in many presentations, several presentations. So if you remember those things, you should be able to straightforward answer. Okay. Next is antenna is here. Is it a transducer or microprocessor or amplifier or something else? Okay. So for this, it's also a straightforward question. So you should be able to answer. At high frequencies, which antennas are widely used? That we need to know. It's quite important, because we cannot use randomly. Though we can use a few antennas, all the frequency range, but some application will not accept that. So we will not have position. We can for example in some application, some frequency application, we will use wire antennas, which will be much simpler than instead of using printed antennas. So that instead of using aperture antennas, in some application we will use aperture antennas, but it would be much simpler solution than the other 2 antennas. So something like that. Okay, it's based on application mainly. So in general, so it's application dependent, but in general, so what we do what antenna we will design when we want to use in high frequency. In general, I'm not asking a specific application. In general, okay. So because Sometimes all the three unders may be used, but answer is not that. I am not intend to question that. So we are not going for a specific application. We are going for few applications. Okay. Next is that VSWR 2 corresponds to return loss value of what? Return loss value of what? So you should remember those formula VSWR 2. So what is the relationship between return loss reflection coefficient to the VSWR? That you should know, so that you should be able to answer this question. I think it's not be return loss, it's I think reflection coefficient. Okay, so sorry for that. So VSWR, there is a relationship between VSWR and reflection coefficient. Please go through that, then you should be able to answer this question straight away. So thank you for your, please do post your comments.